All right, you guys, this is number 12, assignment 1.3. So take a screenshot so you can study. All right, any other homework problems you want me to go over before I start 1.5? And also do me a favor, can you say I'm here in the chat so I know the attendance?
Can we work on 1.4 homework because I ain't know how to.
Yes, 1.4 homework is just fine. We can do that. Work on it. All right, 1 point homework, 1.4. Which number you want to do?
Hold on, I'm gonna get on there right now.
Because we'll do a few, like maybe 1 or 2 problems, and then we're gonna do lesson 5. And if you have time, I will do another homework. Otherwise, we'll wait for tomorrow to do more homework problems. Because you have exam on Tuesday.
Okay, can we do number 3?
Number 3. Okay, number 3. Use the graph to determine the limit. If an answer does not exist, enter DNE. Starting with the first one, A. A, it's asking you C plus X approach to C plus. Okay, C is just a different number, which is what this case they told you C is what? -2. So I'm looking at the -2 here. That's my -2. Looking at from the right, plus means looking at from the right. So I'm gonna draw yourself a line. So this is your right, this is what? Left. Are you with me? That's a positive side, that's a negative side, according to this. C to the positive and C to the negative, okay? So looking at this side, where does this approach to? 2, isn't it? The Y value is what? If Y value were exist, that should be what? 2.
2.
So I'm gonna say 2. The limit is 2. Right, limit is 2. Okay, next one, from the left-hand side. I'm approaching there. What does number this is here again? 2, isn't it? If the Y value exists, it is approaching to this number 2. Just think about what Y value would be if the Y value exists. But remember, this is a circle, okay? It's open circle, so which means you don't have a Y value. So what's my limit? Since my left-hand side is 2, and my right-hand side is also 2, so the limit is what? 2. Are you following me, Avian?
Yes, ma'am.
Okay. And did they ask you one more here? Okay. Okay. Is the function continuous at x equal to -2?
No.
No, because why? It's what? It's open circle, right? So I don't have a Y value. So if I ask you what is f of -2, you're gonna say what? Does not exist.
Yeah.
This is what? Open circle, which equal to what? Does not exist at f of -2, right? You have a limit. Limit means you're looking at from the left-hand side, you look at the right-hand side, they meet together. The specific value looks like where it's approaching. Just look at this graph again. I want you guys to understand between limit and the Y values. All right, did you see? I'm gonna make this graph a little bit bigger. Okay, so this is your C. Okay, looking at that. Because this is an open circle, you're gonna say, oh, actually it's not, does not exist. I made a mistake, right? What is f of -2? Right here, isn't it? Which is what? 3. What's limit x approach to 2 of f of x is what? 2. Okay, are you following me the difference between limit and y value? The y value is this. They gave you closed circle right there. So this value right here, that is your y value at x equal to -2. Okay, and this one right here is open circle. So this is your limit value. Limit at x equal to -2 is 2. Do you see the difference between y value and the limit? Anybody have questions about that? Okay, if you have questions, you need to tell me now or write it down in the chat so I can see. And if you are here, say I'm here, so I know you are here, so I can look at it later. I have a 17 participants, but I only see 5 people say I'm here. So you guys need to say I'm here if you are here. All right, so anybody have a questions about between the limit and a y value? This is a very good problem because this problem tells you the difference between y value and a limit. Okay, Davian, are you with me? Or you still have a question?
Yes, ma'am.
Okay.
I ain't got no question.
All right. Anybody have questions from 1.4 homework that you want me to go over? Anybody else? All right. So you want me to go ahead and move on to 1.5 homework? I mean the lesson? All right, let's go and do it then. 1.5. All right, so we're gonna learn today, we're gonna do infinite limits. Infinite means it's a positive infinity or negative infinity, it's infinity, okay? So we're gonna talk about infinity limits today. So chapter 1 is all about limit, how to find your limit analytically, how to find your limit numerically, how to find your limit graphically. Now we're gonna talk about what kind of limit is there. Sometimes limit can be just a number, a limit can be an infinity. So today we're gonna talk about infinity limit. So determine an infinity limit from the left and from the right. So I'm gonna say from the left and then what? From the right. That's how you do. So if I have a number C, anything to that, in this case it's not infinity. So let me make an infinity limit problem. If I have a graph, so if my graph looks like that, okay, and this is a C positive and this is a C negative side, and you can see it. This graph is keep going up, going toward the what? Positive infinity. This is also keep going up to what? Positive infinity. In this case, I'm gonna say limit x approach to C of this function is infinity. That kind of things, we call it infinity limit. So I'll give you more picture. Now look at this problem. Okay, can you see the numbers? I'm gonna make it a little bit bigger. You see, look at this number. So this means f of 1.5, I get a -6. What's this means? F of 1.9, I get -30. This means f of 1.99 gives me -300. What's going on here? F of 1.999 gives me what? -3,000. I don't know what that is, but what happened to my number-wise? Just look at the numerically, what happened? It's keep increasing, isn't it? Right? So I don't know what 2 is. At 2, I'm not so sure, but let's look at this graph. You see this graph? You see it. This graph is keep going where? Keep going up. What's my, where does keep going up to? What number? We don't know, but it'd be what? Infinity, isn't it? Some huge number. Are you following me? And look at this number. Where does this number goes to? What is that called? When the numbers keep going down, 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 down. What number is that?
Negative infinity?
Yeah, negative infinity. So I have two different limits. So when you're looking at this side, this limit, x approach to 2 from the positive side of this function, I get a positive infinity. And over here, what happened? Limit x approach from the negative side of this function, I get what number? Negative infinity. So I can have infinity as your limit. Okay, limit can be infinity. Used to, remember, would tell them does not exist. Now I can say positive infinity or negative infinity. So that's why I will probably, on your exam, you need to probably say positive infinity or negative infinity, such like that, not just say does not exist, because you will have a limit, one side limit. For this case, class, this case, I want you to remember this. I have one side limit. I have a positive limit to be positive infinity, negative side to be what? Negative infinity, but do I have a the limit? X approach to C of f of x. This case, do I have the limit? Yes or no? I have a one-sided limit. It's a one-side limit. It's negative side and positive side limit. Do I have the limit? Do I have a same number? The left-hand side and right-hand side is the same number or it's different number? All right, I'm asking you guys. Do I have left-hand side limit same as right-hand side limit? Are they same? Yes or no?
No.
You say no? Right, they're not same because the positive side is a positive infinity, negative side is what? Negative infinity. So I don't have the limit. So the limit does not exist. The limit means I don't have anything, I don't put positive or negative, I don't put any of that. Or the limit, I don't have it. Okay, I want you to look at this picture. Okay, I want you to make sure that you understand. This graph we just did, it's a very good problem. Okay. So blue, I'm using a blue as my positive. So I'm asking you limit C, which is X approach to 2 from the positive side. Remember 2 is right here, this connection, this asymptote is my limit I'm looking for. This is a 2. So this, the right is a positive, we'll call it right. This, so we call it left. All right, so to positive side of this function, the 2, look at this, it's going what? Keep going up. It's keep going up. So it's going to be what? Positive infinity. All right, are you following me? What about the negative side? X approach to C from the left-hand side. So I'm looking at this side. This is my left. That's my right. Are you with me? Okay, what's my answer for this function? What does this one keep going to? Edge 2 approach to, where does this go to? It's keep going down, isn't it? So it's negative infinity. So now I'm going to ask you, yes, it does have a one-side limit. If you're looking at the right-hand side, I get a positive. If I look at from the left-hand side, I get negative. Since positive and negative are not same, they're not the same number. So I don't have a the limit. Does not exist. Since what? Positive infinity is not same as what? Negative infinity. Does it make sense to you now, guys? All right, let's move on. So that's what they're talking about. Okay, how about this problem? Let's look at this. All right, this is just the, don't worry about that. Okay, looking at this problem, class. All right, let's look at this function. And this is a 1, that's my C equal to 1. Okay, so this is your dividing line. I'm gonna call this is your positive, and this is your negative. This is my right-hand side. This is my left-hand side. Okay, where does this one goes to? Where's this one keep going up? As X approach to 1, where this one keep going? What is my limit approaching to?
Positive infinity.
That's right. As 1 from the positive side of this function gives me positive infinity. What about my left-hand side? 1 from the left-hand side. Which graph is that? That graph right here. As this one approach to, what happened here? Where does it keep going up?
Negative infinity.
That's right, it goes to negative infinity. No, it's not negative. What is this one? Where does it goes to?
Positive.
This is also positive. Look at this number. Where does this one keep going up? This is your positive number, and this is your what? Negative number. So where does this one also go to? When you're looking at the left-hand side, this also goes to what? Positive. They're both
Positive.
Are you with me? They're both going up. So what is the limit then?
Positive infinity.
Yes, positive infinity, because they both going to what? They're going the same way. They keep going all up. All right. And this one, what about this one? Let me see, do they have any other things I need to go over? So I can just show you a few more examples. Okay. So let me draw here. So this is the one we just did. Okay, now let's look at that. In this case, this is my C, okay? So let's look at my right-hand side limit. Remember, So looking at this, this is my right. This is my what? Left. And this is my dividing line right here. Okay, so let's look at my right-hand side limit first. Limit x approach to 1 from the positive side. That's why I put the positive sign of this function. What's my limit goes to? Look at this 1. Look at this line where this graph is keep going up. Which way this graph is going?
Positive infinity.
Right, going toward the positive infinity. Now let's look at the other side. This is the left-hand side. You look at this. This is your dividing line, right? So look at this graph now to the left-hand side, where this one keep going up to.
Positive infinity as well.
Also positive infinity. From the negative side of this function is also positive infinity. Because of that, because this is the same and that's the same, so what can I say about the limit? X approach to 1 of f of x is equal to what?
Positive infinity.
That's right. Why? Since positive infinity is the same as what? Positive infinity. Right? All right. So do you understand? Let's look at another one. I want to make sure that you know how to do it. I'm not going to do it. I want you to look at this one and tell me. All right. Find me this. Number 1 is that. And I will call your name, so you need to do that for me, okay? Second problem is limit x approach 2 from the negative side. And tell me what that equal to. Number 3, what's the limit? All right, do this problem for me right now. Okay, I'm gonna call your name. So, Shalia, I want you to do number 1. Benjamin, I want you to do number 2. Ethan, I want you to do number 3. And I want you to share your screen, or you can tell me, whichever. All right, who got number 1? Are you ready to do it? Did I say Shalia, you're the number 1?
Is it negative infinity?
That's right. Perfect. Look at this. Where does this go to? Isn't it keep going down? Negative infinity. Perfect. All right, Benjamin. What's your number 2? Where does x approach to 2 from negative side? Where does it keep going up? I mean, where does it go to? Benjamin.
Do we go to positive infinity?
Yeah, look at that. That's right. Perfect. Perfect. Look at this. And where does it keep going?
Keep going up.
Keep going up. So that's why it's a positive infinity. Now, number 3. Ethan, what's my d infinity? I mean, excuse me, where's my the limit at x approach to 2 of this function?
It does not exist because one from the right it goes to negative infinity, and from the left it goes to positive infinity.
That's right. Does everybody agree? We all good now? All right, good job. All right, let's go back to our lesson. Very good, very good. Now, vertical asymptote. So vertical asymptote means you have a function that's a rational function, which means you have a numerator polynomial, numerator function, and the denominator, you have a rational functions, okay? And your denominator is, it goes to 0, then you get a vertical asymptote. Like this problem. So you're looking at this, you set them equal to 0 and figure out what X number that is. That X number is your vertical asymptote. So let's look at this problem. Okay, let's look at this problem. H of X equal to 1 over 2 times X plus 1. Look at this problem right here. Which X can you not use and why? I would set 2x plus 1 to 0, and then divided by 2, x plus 1 equal to 0, minus 1, and x equal to what? X equal to negative 1. So that x equal to negative 1, you get what? When h of negative 1, you get what? Does not exist. So which means x equal to negative 1 is your vertical asymptote. So that's why you have this asymptote right there. That's how you found your vertical asymptote. Vertical asymptote means you have a rational function. You set your denominator equal to 0 and figure out what that x equal to make the denominator equal to 0. All right, there's another case. In this case, look at this. In this case, you have two numbers, x minus 1 equal to 0 and x plus 1 equal to 0. So x equal to 1 and x equal to negative 1. These two are your vertical asymptote. B, comma A, I'm going to call it as a vertical asymptote. Okay, so I don't have to keep writing down vertical asymptote, VA. So that's why you have a vertical asymptote right here, a vertical asymptote right there. Okay, in this case, cotangent cosine x over sine x, you're going to have a many vertical asymptotes because you have a period right here. Okay, next thing, it's important about the infinity limit. The infinity limit, okay, so let C and L be a real numbers and F and G are function is such that the first function has infinity as a limit, and the second function has a number. L is just a number, okay? Just like it says, this is your real number, all right? Then you can do this. It's kind of funny, but look at this one. You can add and subtract. Since infinity is so much bigger than just a number, so infinity plus some number is what? Still infinity. That's why you have an infinity. They were telling you infinity plus some number, that's still equal to infinity because infinity is a huge number. A huge number adding by little number does not make anything difference. It's still a huge number. So that's why it's infinity. Next one. If you multiply those two, you get infinity. So you get positive or negative, all depends. Okay, if it's you multiplying by positive number of the infinity, you get a positive. If you multiply positive infinity with a negative number, you get negative infinity. So positive infinity multiplied by positive number, you get a positive infinity. And negative infinity, positive infinity multiplied by a negative number, you get a negative infinity. That's what they say. And quotients, you get a f of x. Okay, this means a number divided by infinity give you a 0 because infinity is a huge number. So a number divided by a huge number give you what? 0. So you can do that. This is the properties of infinite limit. So let's look at the example. So first one, I'm going to say this limit. I have two functions. This limit is 1, and this limit is infinity. So I have a number as my infinity, and the other one is infinity as my limit. So if I add them together, I get infinity because 1 plus infinity gives me infinity. Okay, next one. This problem, look at this problem. This one, when you're coming from the left-hand side of a 1, I get a 2. This one, I coming from the left-hand side limit of this problem, I get negative infinity. So if I put them together, I get a 2 over negative infinity. Since it's infinity is a huge number, if divided by that number gives me a 0. Okay, any number divided by infinity, positive or negative infinity gives me a 0 because infinity is a huge number. Next one, you're looking at this, x approach to 0 from the positive side, I get a 3. X approach from the positive side of this gives me an infinity. So this really means positive number 3 times infinity, which gives me infinity. Next problem. I have this 0 and I have that, and they're just adding. You have a 0 plus negative infinity gives me negative infinity. So you can do just like your numbers. But remember, infinity is such a huge, huge number. So adding little number to infinity does not change anything. It's still infinity. Okay, it's infinity. Okay, so that's it for the 1.5. So I'm gonna look at your 1.5 homework. All right, so again, you can do this problem. Okay, you can use Julia, or you can use calculator, you can use a GeoGebra, whichever you want to use. So this is how you have to put in your calculator. Okay, this is how you're gonna put in your calculator. You're gonna say f of x equal to, put parentheses, x minus 4 divided by what? Parentheses, x squared minus 5x plus 4. That's how you have to put it in. Okay, so let me do this problem. I'm gonna do it in my Julia. Let me share my screen. All right, so the problem is f of x. Can you see my screen? Yes? I cannot see your face. Let me just make it bigger so I can see your face. All right, can you guys see my screen? Yes? Okay, thank you. I will do x minus 4 divided by x squared minus 5 times x plus 4. Okay, that's my function. Now I want to find which number, f of 3.9. Enter that. That's what my answer. They want you to put 4 decimals. So you need to put 0.348 and you stop, because 2 is what? Less than 5, so you don't round up. So your answer is just a 0.3448. Next one, f of 3.99. Okay, 0.3344, which this next number is still less than 5, so 0.3344, that's it. F of 3.999, you get 0.3334. Okay, the next one, f of 3.9999, 0.3333. All right, are you with me? So it looks like to me, Okay, what's next? After that, they're asking you, they say, looking at this from the right-hand side. So I'm gonna do 4.00001. You get 0.3333. So just looking at this, I can see your limit is approaching to where? 0.3333. All right, so that's how you're gonna do this problem. So let me share my screen again. Okay, so that's why when you look at this problem, that's why your answer is what? 0.3333. All right. All right, now let's look at other problems. So today we're finished by 10:45, okay, 10:50. So don't worry about it. Today's not 2 hours because I know you have a class at 11. All right, now look at this graph. Use the graph to find the limit if it exists. So they want to know at x equal to 5. So x equal to 5, that's my C. Where does this limit approach to? In this case, it's a solid. So my limit is the same as f of 5. All right, so now tell me what's my y value at here? 5 comma what? What do I need to put here? You look at this, right? You look at over here to figure out what my y value is, which is what? 2. In this case, it's all 2. All right, are you following me? Yes? Okay. So I can look at it graphically, and I can also do what? Simply plug it in. I plug it in. Then 7 minus 5 gives me what? 2. Either way, they're same number. Okay, what about this one? Look at this problem. What is my limit? Hold on, am I looking at the right problem? It's 1.2, isn't it? Oh, so I was looking at the wrong problem. Okay, let me go back. 1.5 is the one I need to look. All right, 1.5. Sorry about that. 1.5 limit. Okay, so I want to find the limit at 6 from the left-hand side. So so this is my graph that I'm looking at. So this is a 6, this is a positive side, and that's negative side. So where does this negative side approach to? Where does my limit goes to from the negative side? Somebody tell me. Where does this approach to?
Positive infinity.
That's right. So limit x6 approach from the negative side of this function is positive infinity. All right, next person. Thomas. Tell me where this 6 from the positive side, which means this graph, where does this limit goes to approach to?
Positive infinity.
That's why it also goes to positive infinity. All right. Stephanie, what's my limit at 6 then?
Positive infinity.
All right, why?
Because they both equal positive infinity.
Both positive infinities, right? All right, let's look at the -6 now. Now, whom did I not call? Okay, James. I want to look at this graph right here. So limit of f of x, -6 approaching from the positive side, where does it go? What's my limit? At,
Positive infinity.
that's right. Because it's definitely a negative. This is a positive side of -6, and this is what? Negative side of -6, right? Okay, next person. X approaches -6 from the negative side. All right, Margie, what's my limit? At x, approach to -6 from the negative side.
Positive infinity.
Right. Now go ahead and finish the problem for me. What is the limit of x approach to -6?
Positive infinity because they're both positive.
Everybody understand about how to do infinity limits? Okay. Let me see. Is there anything else? About that. Okay, now look at this problem. Determine whether f of x approach to positive infinity or negative infinity as x approach to 6 from the left and from the right. So we know what to do. We've been doing this one, so I need to figure out, I need to look at the 6. So I don't care about any of this number. Only thing I care about what? That number. So I have a positive is this side, and this is a negative side. So let's just see it. So if I'm looking at the limit, x approach to 6 from the positive side of this function, so this is a graph that I need to look at it. What happened to this graph? Where does this one approach to? Negative infinity, isn't it? Because this part right here is keep going down. Okay, what about that same number from the negative side? It is what?
Positive infinity.
Keep going up. So I can say clearly of this function of the limit is what? Does not exist, because you know negative infinity is not the same as positive infinity, right? All right, so that's it for today. So you guys need to finish, okay? You need to finish your homework. All right, you need to finish, okay, you need to finish your homework. All right. Make sure that you do all your homework problems so you can ask me whatever you have. Okay. Did you also put here? So I know you are here.